Greetings, M squared here. Today we're going to talk about transformations again, but we're going to talk about it with exponential equations. So the cool thing is no matter what function you're talking about, these transformations work. So we're only going to be talking about horizontal and vertical translation. So a translation is just a slide. So we take our original a times b to the x. We know that. What do we know about this? Let's talk about what we know. We know a is the y-intercept. We know that b is the constant ratio. We know that x is the exponent. And we know that the domain is all real numbers. The range is y is greater than 0. And the asymptote is y equals 0. So when you think about all the things you know about this and then think about shifting it left, right, up, or down, some of those things are going to change. So the asymptote is going to change. The range is going to change. Domain will stay the same. So some things will change and some things will remain the same because we're just moving, remember, this is what it kind of looks like. And so we're just moving up, down, left, and right. So what moves things up and down? It's still the same as what we did before when we did absolute value functions. This h that's with the x moves it left, right. And again, when it's a minus, remember the formula is minus. When it's a minus 5, that means it moved right 5. When it's plus 6, that means it moved left 6. This k is going to move things up and down. So if it's plus 2, it's going to be up 2. Minus 7, down 7. So if you just remember those, hopefully you remember them from absolute values, that's what's going to happen. So we got our up, down right here with k. We got our left, right here with h. So basically, I'm going to ask you to compare functions to some function that I give you. So I'm giving you 3 to the x. Well, how is this function different than that function? So all you have to do is tell me how many units it moved left or right or up or down. We're not going to do any stretching or shrinking or anything like that. We're just doing these two for exponential functions. So since it's with x, we know it moves left or right. Since it's a minus 7, we know that it moved right 7. So we're just going to say right 7. This 4 is not up in the exponent. So this tells us it's an up or down. So because it's plus 4, I know it moved up 4. This negative right here, I shouldn't have put that there because we're not supposed to talk about that. We're not going to talk about that right now. But we're just going to talk about what these guys do. So what does the plus 5 do? It moves it left 5. And what does the plus 2 do? Because it's not in the exponent, it moves it up 2. And I should have written this with a parenthesis, so my apologies on that, because our constant ratio is 2/3. So what does the x plus 8 do? Well, because it's with the with the x, that plus 8, I know it moved left 8. And here again, I forgot my parentheses on these. So on this one, it's not up with the exponent, so that means it's up or down, and since it's negative, it's down 10. And over here I have both things going on, so I know it moves right 4 and up 11. So you just have to remember that when it's up with the exponent, it's on left or right, opposite of what you would think, and when it's not in the exponent, it's up or down. Sometimes you are going to have to look at the tables to evaluate it. So we know this is the original function. So let's keep in mind that when we have a 0 there, that's a 1. So what I like to do is I like to look and see where I got a 1. I got a 1 at 2. So that means that something had to happen to where we put a 0 in. I got a 2 as my when I put a 2 in, I get a 0 for my exponent. Well, what can I do to 2 to get a 0? Well, it would have had to have been a 2 minus 2. So we would have had to have had an x minus 2 as the exponent. So it would be 2 to the x minus 2. And then I just see if it works. So what if I put a 3 in there? What's 3 minus 2? So I'm checking this point out. What's 3 minus 2? It's 1. Is 2 to the first power 2? Yeah. So I'm pretty sure that's my expression. So how is this different than that? We're comparing it. Well, it's right. It was shifted to the right 2 units. That's how it's different than that. In this one right here, I don't notice any 0 or 1, 1 here. I notice that my y-intercept is -4 though. but I think it's shifted. So sometimes what I do is I look and see what's happening, and I notice that it's getting closer to -5 but hasn't quite reached it. That would tell me that my asymptote just changed from 0 to -5. Like, look at what this one's happening to this one. 2, 1, a half, a fourth, an eighth, a 16th. Well, that's not supposed to be there. I think I missed a 0 there. Sorry about that. But it's getting smaller and smaller, not bigger. So I know that my asymptote is 0 here. It's still y equals 0. Where over here, I realize that my y asymptote is going to be at -5. So when I have some expression that's something to the x, so we know it's 2 to the x, I know that it's a -5 because I think that's my new asymptote. So now I'm going to check it out. So I look for the asymptote, and then I know that whatever that number that it's approaching is, it's probably my horizontal shift, my up and down shift. So let's just plug something in. I'm going to plug 0 in. What's 2 to the 0? It's 1. What's 1 minus 5? So 2 to the 0 was 1. 1 minus 5 is -4. Yep, that's what it is. So this would have been my function. So now I have to compare it to the original equation, and it looks like it's just down 5. So we've got to kind of do a little bit more kind of thinking on those. Look at your asymptote. Look at where it's 1, and those should help you out. So that's translations with exponentials. Good luck with that. N squared signing out.